Have you ever wondered what would happen if you fell into a black hole? Imagine, if you will, an enigma, a puzzle so profound that it has intrigued and puzzled the greatest minds for centuries. This enigma, my friends, is the black hole. A black hole is a region in space where the gravitational pull is so powerful that nothing, not even light, can escape its grip. It is as if the universe decided to play a game of hide and seek, concealing these cosmic beasts in the shadows, far from prying eyes. It's a cosmic trapdoor from which nothing returns, a one-way ticket to who knows where. Black holes are the universe's ultimate enigma, a mystery wrapped in a riddle, shrouded in the inky blackness of space. But what exactly is a black hole? Well, let's break it down. Think of a black hole as a cosmic vacuum cleaner with an insatiable appetite. It's a region in space where gravity is so strong it warps the fabric of space and time around it. This intense gravitational pull is what makes a black hole, well, black. It's so strong that not even light, the fastest thing in the universe, can escape its clutches. Imagine standing at the edge of such a fearsome creature. You would feel its pull, like a cosmic tug of war. And if you were to fall in, well, let's just say it's a trip one does not come back from. Black holes are more than just the stuff of science fiction. They're a fundamental part of our universe, playing a crucial role in the life cycle of stars and the formation of galaxies. Yet, despite their significance, they remain largely a mystery. So where did we first get the idea of these invisible, inescapable monsters of the cosmos? The concept of black holes didn't just appear out of nowhere. It was born out of the genius of one man's mind. That mind was none other than Albert Einstein's. A century ago in 1915, Einstein proposed the revolutionary theory of general relativity, forever transforming our understanding of gravity and the very fabric of the universe. In essence, the theory of general relativity posits that massive objects cause a distortion in space-time, which is perceived as gravity. Here's where it gets exciting. When an object is so dense and massive, it can cause such a profound distortion that nothing can escape from it, not even light. This is the theoretical birth of a black hole. But how did we move from theory to the concept of black holes we know today? Enter physicist Carl Schwarzschild. In the year following Einstein's proposal, Schwarzschild provided the first exact solution to Einstein's field equations, a solution which described a black hole. Schwarzschild's solution painted a picture of a point in space where gravity is so strong that it forms a one-way door, a point of no return. He called this the event horizon. Yet, even with this solution, the scientific community was skeptical. The idea of a region of space where time stops and nothing can escape was simply too strange, too far removed from our everyday experience. Many saw black holes as a mere mathematical curiosity, an oddity arising from the equations, but not something that could exist in reality. It's important to understand that science doesn't progress in leaps and bounds, but rather in small, measured steps. Each discovery, each theory, is meticulously scrutinized, tested, and challenged. This is the essence of the scientific method. So, while the theoretical foundation for black holes was laid in the early 20th century, it would take many more years of observations, debates, and paradigm shifts before the existence of black holes was generally accepted. The journey from theory to acceptance was long and arduous, but it resulted in one of the most fascinating concepts in modern physics. But it would still take many decades before the existence of black holes was generally accepted. The hunt for black holes was not an easy one. It took decades of tireless work and the development of new technology. If we rewind time and journey back to the latter half of the 20th century, we'll find ourselves in the midst of a thrilling cosmic chase. Scientists were on a relentless pursuit to detect these elusive entities, black holes, that were merely theoretical at this point. Picture this. The year is 1964. A new player enters the scene of space exploration: X-ray astronomy. This innovative approach to observing the universe allowed us to detect phenomena that were invisible to traditional telescopes. The universe suddenly became a lot more interesting and a lot more mysterious. Fast forward to 1971. The spotlight is on an X-ray source in the constellation Cygnus, aptly named Cygnus X1. It turned heads not just for its brightness, but for its peculiar behavior. Its X-ray emissions were fluctuating wildly, a characteristic that scientists believed could only be explained by the presence of a black hole. Cygnus X1, ladies and gentlemen, was our first strong black hole candidate. But the journey doesn't end there. In fact, it only gets more exciting. Scientists had to develop crafty methods to study these invisible space giants. One such method was to observe the behavior of visible matter nearby. A black hole, after all, is like a cosmic vacuum cleaner, sucking in everything that gets too close. And as matter spirals into a black hole, it heats up and emits X-rays. By observing these X-rays, astronomers could infer the presence of a black hole. Yet, it was not until the dawn of the 21st century that we had the technology to truly confirm the existence of black holes. Thanks to advances in equipment and techniques, we were finally able to make the first direct observation of a black hole. A major milestone in the history of astronomy indeed. The hunt had been long and grueling, but the rewards? Absolutely cosmic. Finally, in the 21st century, we had the technology to make the first direct observation of a black hole. In 2019, humanity got its first glimpse of one of the most mysterious objects in the universe. This marked a pivotal moment in our quest to understand the cosmos, and it was made possible by the Event Horizon Telescope project, an international collaboration involving over 200 scientists across the globe. The Event Horizon Telescope, or EHT, is not a single telescope, but rather a network of 8 radio observatories spread across the world. Together, they form a virtual planet-sized telescope, capable of capturing images with unprecedented resolution. The EHT's goal was ambitious: to image for the first time the event horizon of a black hole. The event horizon is a boundary in space-time beyond which events cannot affect an outside observer. In layman's terms, it's the point of no return. Anything that crosses the event horizon, be it light or matter, is forever trapped by the black hole's immense gravity. This makes the event horizon incredibly difficult to observe directly, as not even light can escape it. And yet, in April 2019, the EHT team released the first ever image of a black hole's event horizon. It wasn't a Hollywood-style spectacle, but rather a blurry orange ring of light encircling a dark void. That void is the shadow of the black hole, more than 6.5 billion times the mass of our Sun, located in the galaxy M87, 55 million light-years away from us. This achievement was monumental for several reasons. It provided the first direct evidence of a black hole's existence, confirming predictions made by Einstein's theory of general relativity over a century ago. It also gave us valuable insights into the behavior of matter and energy in extreme conditions, furthering our understanding of the universe. But even with this direct observation, there's still so much we don't know about black holes. Their mysteries continue to captivate us, pushing the boundaries of our knowledge and imagination. As we delve deeper into the cosmos, who knows what other secrets we'll uncover? The study of black holes is a rapidly advancing field, with new discoveries being made all the time. In recent years, our understanding of these cosmic beasts has been revolutionized by the detection of gravitational waves. These ripples in the fabric of space-time are created when black holes merge, an event so powerful it sends shock waves rippling across the universe at the speed of light. The detection of these waves has opened up a whole new way of studying black holes, allowing us to probe their properties and behaviors like never before. We've also seen the discovery of a new class of black holes: intermediate mass black holes. These are black holes that are significantly larger than those formed from the death of a star, yet smaller than the supermassive black holes found at the center of galaxies. Their existence has long been theorized, but only recently have we started to find concrete evidence of them. This is a big deal because it could help us understand how supermassive black holes, which can be billions of times the mass of our Sun, are formed. One way we think this might happen is through the gradual accumulation of mass by intermediate mass black holes, acting as a stepping stone between stellar black holes and their supermassive counterparts. But there's still much we don't know. For instance, how do these intermediate mass black holes get so big in the first place? And how common are they in the universe? These are questions that researchers are actively trying to answer. Another exciting development is the use of black holes to test the limits of Einstein's theory of general relativity. So far, it's stood up to every test we've thrown at it, but black holes offer extreme environments where its predictions could potentially break down. This could lead to new physics, and perhaps even a deeper understanding of gravity itself. With every new discovery, we're getting closer to understanding these enigmatic objects. So, what's next in the quest to unravel the mysteries of black holes? The answer to that is as vast as the universe itself, filled with possibilities and potential discoveries that could revolutionize our understanding of the cosmos. The study of black holes has always been a field of relentless innovation and curiosity, and the future seems to be no different. One of the most intriguing prospects lies in using black holes as laboratories to test theories of quantum gravity. Yes, you heard that right. Black holes, those insatiable devourers of matter and light, could be the key to unlocking the secrets of quantum gravity, a theory that seeks to reconcile the seemingly incompatible worlds of quantum mechanics and general relativity. The idea is that black holes, with their extreme gravitational fields, could be the perfect sandbox for studying the effects of quantum gravity. They could provide us with the unique opportunity to observe how the quantum realm behaves under extreme conditions, potentially leading to breakthroughs in our understanding of the universe's fundamental laws. But that's not all. The future of black hole research could also see advancements in our technological capabilities. The development of new and more powerful telescopes could allow us to observe black holes in greater detail than ever before. We might even be able to detect the elusive gravitational waves produced by black holes, giving us a new way to study these cosmic enigmas. And who knows? Perhaps one day we may even find a way to safely explore these gravitational giants up close. While this might sound like the plot of a science fiction novel, remember that many of the technologies we take for granted today were once the stuff of science fiction. In the end, the future of black hole research is a journey into the unknown, a voyage into the heart of the universe's deepest mysteries. It's a journey that will challenge our understanding, push the boundaries of our knowledge, and hopefully bring us closer to answering some of the most profound questions about our existence. While there's still much we don't know, one thing is certain: the future of black hole research promises to be exciting. We've journeyed from the birth of the concept of black holes to the latest cutting-edge research. It's been quite the cosmic trip, wouldn't you say? Let's take a moment to pull back and look at the larger picture we've painted today. In the beginning, we dived into the enigma of black holes, these elusive celestial objects that have intrigued scientists and laymen alike for centuries. We explored how their existence challenges our understanding of the universe and the laws that govern it. From the bizarre physics that allows for their creation to their invisible nature that makes them so hard to detect, black holes are truly a testament to the mysteries of the cosmos. From there, we embarked on the journey of a star's life, leading up to its spectacular death and transformation into a black hole, a stellar collapse, a supernova explosion, and finally, the formation of an entity with a gravitational pull so strong, not even light can escape it. The birth of black holes, it seems, is as dramatic as the celestial bodies themselves. Then, we took a detour to join the hunt for black holes. We learned about the ingenious methods scientists use to detect these elusive entities, from observing the behavior of nearby stars to detecting the ripple effects they cause on the fabric of space-time. It's a cosmic detective story like no other. Our journey brought us to the historical moment when we captured the first picture of a black hole. It was an achievement that marked a new era in our understanding of these celestial enigmas. A blurry ring of light, circling an abyss of darkness, gave us the first tangible proof of their existence. Next, we delved into the latest research on black holes. We discovered how they influence the formation of galaxies, their role in the cosmic web that connects the universe, and how studying them could potentially unlock the secrets of quantum mechanics and gravity. The more we learn about black holes, the more we realize how integral they are to the workings of our universe. Finally, we looked towards the future, to the exciting possibilities that lie ahead in black hole research. From the potential to use black holes as a source of energy to the tantalizing possibility of wormholes and interstellar travel, the future of black hole research seems brighter than ever. And so, we've come full circle. From their birth to their role in the cosmos, black holes continue to captivate us with their enigmatic nature. The more we learn, the more questions we have, and that's the beauty of scientific exploration. So, the next time you gaze up at the night sky, remember, there's a whole universe of mysteries out there just waiting to be discovered.